Okay, welcome back, Alg 3 Trig. We are in section 3.1. Today we're going to do two different topics. The first one is we are going to learn how to simplify I with a power. So let's focus in to the right here. Let's add these four things in blue to your notes. We know that I to the power of 0 is 1. Well, the reason that is anything to the power of 0 is equal to 1. That's an old Algebra 1 property. I to the power of 1 is equal to I. That one's pretty easy to understand. Anything to the power of 1 is just itself. You don't need that power of 1. I to the power of 2, we learned that in a previous lesson, I squared equals -1. And then a new one is I to the third power equals -I. There is a reason for that. I'll show you really quick. Not that you need to memorize this, though. I to the third power is the same thing as saying I to the second times I to the first. We know that I to the second is -1, and I to the power of 1 is I, and -1 times I is -I. Again, you don't need to memorize this. It's just in case you're wondering why I cubed is equal to -I. Okay, so what happens if we have exponents that are to a much higher power, such as in example A? We're going to learn how to simplify I to the power of 37. In order to do this, we have to take 37 and divide it by 4. You might be wondering why the number 4. Well, there's 4 properties on the left side of our screen right now. So divide by 4. 4 goes into 37 9 times. Multiply to get 36. And then subtract to get a remainder of 1. That remainder of 1 is very important. Don't worry about the 9, by the way. The remainder of 1 means that I to the power of 37 is the same thing as I to the power of 1. And if we look to the left, I to the power of 1 is just I. Moving on, 58. Now we're going to take 58 and divide by 4. 4 goes into 5 one time. Multiply 1 times 4, bring down the 1, bring down the 8. 4 goes into 18 4 times. 4 times 4 is 16. And then subtract, you have a remainder of 2. Again, the 14 doesn't mean anything. It's the remainder of 2. So that means that I to the power of 58 is the same thing as saying I to the power of 2. The remainder becomes your exponent. And look at the left of the screen. We know that I to the power of 2 is -1. So -1 is our answer. Now I to the power of 75. Take 75, divide by 4, and let's see what remainder we're going to get. 7 divided by 4 goes into 7 one time. 1 times 4 is 4. Subtract to get 3, bring down the 5. 4 goes into 35 8 times to become 32. 8 times 4 is 32. So there's your remainder. Don't worry about the 18. All we care about is the remainder. So that means I to the power of 73, I to the power of 75 is the same thing as I to the power of 3. And we refer back to the left. I to the power of 3 is equal to -I. Now let's see for I to the power of 80. So 80 divided by 4. 4 goes into 8 twice. Bring down the 0. And that would be 0. Well, we have no remainder here. So remainder of 0 means that we go back. I to the power of 80 is I to the power of 0. And what will that become? I to the power of 0 is equal to 1. Remember that anything to the power of 0 is equal to 1. All right, so that'll set you up for down here. If you scroll down to assignment 3.1b, you're now good to do numbers 1 through 4. Okay, now let's do some more. Conjugates and division. The conjugate of a plus b is a minus, the conjugate of a plus bi is a minus bi. So conjugates of one another, as you can see in example 5a. 5 plus 7i and 5 minus 7i are conjugates. And when we multiply two conjugates together, it's actually going to simplify to end up being a real number. So let's show you some proof here. And by the way, this multiplying by conjugates is going to help us to do example 6 down below. All right, so we're obviously going to FOIL here. We have a binomial times a binomial. So first, outer, inner, and then careful with the last. That would be negative 49, and then I times I is I squared. Now, take a look at the two like terms here. They cancel out. One's a minus 35i and a plus 35i. They add up to 0. So get rid of them. Bring down the 25. The minus 49i squared, remember I squared is negative 1. So negative 49 times negative 1 is 49. So put plus 49. And then we can add those to get 74 is our answer. So just as I said, we multiplied two conjugates and we got a real number as an answer. Letter B, these are actually also conjugates, 8i and negative 8i. When we multiply them, it's going to be negative 64i squared. So that becomes negative 64 times negative 1. I squared turns into negative 1. And that'll be negative times a negative is a positive, and there's your answer. Okay, so let me show you another one. This is actually from your homework that you're going to have, assignment 3.1b. I'll help you out with number 6. So we have to FOIL here again. So first, outer, inner, and last. All right, so negative 6i plus 6i add up to 0, so get rid of it. Bring down the 9, and then minus 4 times negative 1 for the I squared. That'll become 4. So put a plus 4, and then add to get 13, and there's your answer. So again, multiplying conjugates gets you a real number answer. All right, why is that important leads us to the next part. If we have a fraction, there's certain rules for fractions. The denominators are not ever allowed to have 0 in them, or else it's undefined. They're not allowed to have radicals in them because they're undefined. You guys have learned those two things before. But there's a new one. It says that in a denominator, we are not allowed to have the imaginary number I. So what we're going to do is multiply by a special fraction, and you'll see once you multiply it out that it'll turn the denominator into a real number. So in order to divide 2 minus 5i divided by 1 minus 6i, we have to multiply by a fraction. And if you take a look, the denominator is 1 minus 6i. So what you're going to do in your fraction that you're multiplying by is do the conjugate of 1 minus 6i, which is 1 plus 6i. So we're going to FOIL the top, combine like terms, FOIL the bottom, combine like terms, and simplify. All right, let's FOIL the, so again, I'm going to be foiling the top and the bottom. First times first, outsides, inside, and last. Now I'm going to keep simplifying. Plus 12i minus 5i is 7i, so plus 7i. And then this becomes negative 30 times negative 1. The I squared turns into negative 1, which will be plus 30. And then we can add the 2 plus 30 together to make 32 and carry over the plus 7i. Okay, now let's FOIL the denominator. These are conjugates, so I'm expecting a real number denominator. So actually, let me do a different color. First, outer, inner, and last. These two add up to 0, so get rid of them. Bring down the 1. Minus 36 times negative 1 is 36. So put plus 36. And then 1 plus 36 is 37. Now, I didn't say our answer was going to be pretty. This is our answer. All we did was divided and we simplified here. And we do take a look and go, okay, can I reduce this fraction? Nah, 32 doesn't divide with 37. 7i doesn't divide by 37. So that's done there. And that met our goal. As I said earlier, we're not allowed to have an imaginary number in the denominator, so we got rid of it. Okay, so let's get rid of the imaginary number here. We're going to divide, but we're really going to multiply. So we look at the denominator. It says 7 plus 4i. So the conjugate of that is 7 minus 4i. So we're going to FOIL the top and FOIL the bottom. So first, outside, inside, and last. Okay. So we're going to combine like terms. Let's bring down the 35. Negative 20i plus 14i is negative 6i. And then the negative 8 times negative 1 because of the I squared. So that'll be negative 8 times negative 1 will be 8, so plus 8. And then go one more step further there. 35 plus 8 is 43. Okay, so now we're going to FOIL the denominator. First, outside, inside, and last. So bring down the 49. These two guys add up to 0, so they'll cancel as expected. And then minus 16i squared, that's minus 16 times negative 1 is plus 16. And then we're going to add 49 plus 16 to have 65. And then I look and I go, okay, can either of those numbers reduce with 65? No, they cannot. So there's my answer. Okay, let's do one more, then we'll be done. I'll help you out with another homework problem here. go down to assignment 3.1b. I'm going to help you out with number 9. So here, we're going to we have I in the denominator, not okay. So the conjugate of the denominator is 5 plus 11i. We're going to distribute the numerator. So 3 times 5 is 15. 3 times 11i is 33i. And we're good there. That's done. Now the denominator, we're going to FOIL. First, outer, inner, and then last. It'll be negative 121i squared. And if there's anything you got to be really, really careful about, remember when you have I times I, it'll become I squared. Okay, after that, these plus 55i minus 55i cancel out. They add up to 0. Let me bring down my numerator. 25 is going to drop down. And then this becomes negative 121 times I squared is negative 1. So that's positive 121. And then we're going to add those together to get 146. And then bring over the numerator. And then I do a double check. Can both of those numbers simplify with 146? No, they cannot. So there's my answer. Okay, guys, so you should be good to go on 3.1b to finish up what I didn't get through, 1 through 12.